I'd like to start today with a warm-up. Please identify which tables represent functions and which graphs represent functions. Take a minute to decide. Pause your video, and when you're ready for the answer, press play again. Okay, so for my first table, it is a function because every single x has exactly one y. I can also tell by looking at this and seeing that no x value repeats. In table 2, it's not a function because I have 4. That goes to -2, but 4 also goes to +2, so that's not a function. In my first graph, we look at a graph by deciding whether I can draw a vertical line and have it intersect my graph in more than one spot. You can see with the first graph, anywhere I draw that vertical line from the far left to the far right is only going to intersect my graph in one spot, so that is a function. My second one is not. You can see that this one fails the vertical line test. It intersects my graph in more than one spot, so that's not a function. So this is the second day of functions today. We are going to talk more specifically about domain and range of functions. So first we need to define the domain and the range, kind of did yesterday, but we're going to do it a little bit more formally now. The domain is the set of all x values, and it is a set. And the range is the set of all y values. And again, it's a set of points. Now, let's take a look and see what this looks like graphed. There is a difference between a discrete and a continuous function. So just to read what's here, identifying the domain and the range from a table of values becomes tricky depending upon whether that table of values represents a discrete function or a continuous function. A discrete function is represented numerically by a table of values that define points on a graph and that are not connected. A continuous function represents a table of values that define points on a graph that are connected. So we're going to compare the two. I want you to plot all of these points here and here, and when you're ready for the answer, press play. Don't worry about filling out the domain and the range yet. Ready? Go. Okay, so this is what you should have done. You can see I have my points drawn here. They're not connected. Here they are. So identifying the domain, remember it's a set. So we're going to write it as a set. So in the first case, I can just list the x values for the domain. -5, -3, -1, 0, 1, 3, and 5. For my my range, those are my y values, so I'm going to list them. 5, 2, 0, -2, 4, 6, and 8. Now, in the second graph, all the x values between the lowest x value here at -5 up to the highest x value at 6 have points associated with them. So like at 4.5, or even at 4, I have a y value of 7. So I have to list all the x values, and there are infinitely many between here and here. So what I have to do is use interval notation. So I would write my lowest one, and it's a square bracket because -5 is included, from -5 to +5, also included. So that's the set of all points between -5 and +5. My range are the set of all y values, and that's going to be from my lowest y value, which is -2, and it includes that, up to my highest y value at 8, again, includes that. So now let's look at these and decide what the domain and the range are. So in my first example, my x values, and again, I don't have the table, but I can tell my lowest x value represented is -5 up to 2. So this would be -5 to 2. Again, it includes the -5 and it includes the 2. My range goes from my lowest y value at -5 up to +3. So -5 to +3. In my next one, again, lowest x value to highest x value is the domain. My lowest x value is -4 to +3. My range, lowest y value up to the highest y value, so -5 up to +3. And then finally, looking at the arrows on each side of this, you can see that this graph is going to continue on this way to infinity. This one's going to continue on this way to infinity. So this covers all of my x values, -infinity to +infinity, and it covers all my y values, -infinity to +infinity. Now, I just want to note one more thing. If this was an open circle, it would mean it does not include 3, the point 3, 1. So I would have to change this to be a curved parenthesis. So now I want you to give the next ones a try. Press pause on your video feed when you're ready for the answers. Press play again. So looking at this, in my first example, all of my x values are represented, -infinity, +infinity. Notice the curved parenthesis on infinity and -infinity. You can never include infinity. The range goes from 0 to infinity. It includes 0, since this point is -3, 0. My next one, my domain goes from -4 to +infinity. Notice the open circle here. That's why I have a curved parenthesis there. The range goes from -infinity up to, but not including, 5. In this one, my domain goes from -5 to +4, inclusive, because these are closed circles. My range goes from -1 up to +3, inclusive, because of the closed circles. Next one, my domain covers values from -4, including that point, because it's closed, up to +4, curved parentheses, since it's an open circle. And my range goes from -3 up to +3, but does not include +3. Number 8, my domain goes from -5 up to +3. This does not include the 3 since it's open. My range goes from -1 up to +5, curved, since it does not include this point. Here, my domain excludes the x value at 1. So remember that interval notation goes from low to high. So this goes from -infinity up to 1, curved, not including it, and then goes on to positive infinity here. So it includes all my x values except this one. Now I need to change my answer for the last one, the domain. I'm sorry, the range. Let me talk about why. So my range goes from -infinity to positive infinity. And the reason is because even though this point is excluded from my y's, I still have another y value over here. So it's covered. So from -infinity to positive infinity. You can imagine, think about the axis as a screen projector. Well, no, the screen from a projector, and you're shining lights towards the axes from both sides. What you're really talking about is where the axis is shaded. So even though if I'm shining a light, it doesn't get shaded from this point on the 1, it would from this one, so it covers all y values. Okay, Next, I'd like you to do your homework assignment that's posted online. Have a great day.